Welcome to Straight Lines Critical Questions. So this is meant for this is the second part of the video. This is meant for the students class 11th and 12th who are going to write board exams as well as engineering entrance exams. Okay, so let's learn few some more theory. We did not cover the pair of straight lines in the previous video. We'll cover that one and then get into the critical problems. Okay, so what is the homogeneous equation of pair of straight lines? Okay, this is nothing but we already know what is the straight line equation. Okay, and if you want to represent pair of straight lines, that is two straight lines in the same equation, what you will do, you can actually multiply both of them, correct? If it is ax plus by plus c equal to 0 and dx plus ey plus f equal to 0, then multiply both of them, you get a equation, combined equation in terms of x square, y square and xy, the next term, y term and constant term you get. Okay, this is called the pair of equation of pair of straight lines. Okay, among that you have two types, homogeneous and non-homogeneous. Homogeneous is the one which goes where the both straight lines goes into the origin. That means there won't be any constant term. Okay, in the case of non-homogeneous equation, you will have every term possible. Okay, let's see this, the representation. Okay, so homogeneous equation is simple, ax square plus 2hxy plus by square equal to 0. This is how we represent the equation. Okay, the notation a, b, h, all these are all fixed for homogeneous as well as non-homogeneous. So you have to understand how it has come. Okay, so in homogeneous equation, you will have only three terms, x square, y square and xy term. Okay, this is the pair of lines passing through the origin. Okay, non-homogeneous or general form of the equation is this one, ax square plus 2hxy plus by square, okay, plus 2gx plus 2fy plus c equal to 0. Okay, so only thing is remember how the each term is written. First is x square term, then you have a xy term, okay, then you have a y square term, then you have a x term, y term and constant term. Okay, so what are my ABC? X square term, y square term and constant term. These are my ABC coefficients. Okay, coefficients of them. Then I have to DE, if I remove, then A, B, C, D, E, F, G, H you have, right? F, G, H. These are the coefficients of 2F is the basically double the F. Okay, 2F is the coefficient of Y. Okay, 2G is the quotient of x term and 2H is the quotient of xy term. Okay, so this is how we should remember this. Okay, this is the way to remember, since everybody is using the notation in the same way, so you should remember this one. Okay, this is the general equation of a non-homogeneous equation. So this equation can be a pair of straight lines, it can be a hyperbola, it can be something else also. Okay, so in this equation there is a condition, only if you meet that condition, then actually you can say that this is a pair of straight lines. What is the condition? Okay, the condition is this one, ABC plus 2fgh minus af square minus bg square minus ch square equal to 0. This is the condition you have to meet to tell that this equation is a pair of non-homogeneous straight lines. Okay, non-homogeneous equation of a pair of straight lines. Okay, so how this condition is coming, we can I will give you the determinant form also, very easy actually. Okay, and if these are the pair of straight lines, then the angle between those lines is given by tan theta equal to absolute 2 times square root of h square minus ab by a plus b. Okay, remember this is 2h. Okay, coefficient is 2h, not h. Okay, so don't take xy coefficient as is and then do a square. Okay, you have to take half of it. That is important. Okay, okay, it's nothing but you will get actually b square minus 4ab, if you b square minus 4ac, right? If this is b, this is c, then b square, okay, minus 4ac, that's what you are getting, correct? If you represent that way, right? So this is very similar to the quadratic equations, you will easily understand, just need a practice. Okay, so this is the angle between the lines. Then sum of slopes is minus 2h by b, minus 2h by b, sum of slopes. Product of slopes is a by b. Okay, and then parallel or coincidence lines condition is h square equal to ab, this is one condition, or you can more general form is h by a equal to b by h equal to f by g. Okay, h by a, okay, see here, h by a, okay, b by h, b by h again here, then f by g. Okay, so this is 2 times, right? Xy term is there, so first is x square by, sorry, xy by x square, that is h by a, then y square by xy term, that is b by h, then f by g, y by h, x. Okay, so this is how you should remember. This is the condition for coincident or parallel lines. Okay. Next is perpendicular lines. If a plus b equal to 0, then they are perpendicular. Okay. Then equally inclined to axis. If it is h is equal to 0, then they are equally inclined to axis. Okay. So these are the things which you should remember. And the condition part actually, always you have to check if it is not given. Okay. If the equation is given and it is not told that it is a pair of straight lines or something else, you have to always check the condition if it is a pair of straight lines or not. Then you can apply all this formula. Okay. So how that can be done? Okay. So this is the determinant form of the condition, that is, okay, determinant of a, h, g. Okay. A, h and g. What is this? All three have x in it. X square, xy term and x term. Okay. And make sure that you get g and 2h. It is half of this coefficient you have to get. Okay. Not, be careful about that one. A, h, g. And vertical also AHG. Okay, similar, right? It is a this matrix is mirror image basically, right? And then in the diagonal you have ABC. Okay, A, B, and C. Okay, H is here, so H is repeated here. G is here, X term basically first row is X term as it, so G is here. Then remaining is F, Y term is here. Okay, Y is here. So this is, if you calculate this determinant, it is same as what you are seeing here. ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. If this condition is met, this is the pair of straight lines. Okay. Yeah, hope you understood this concept of pair of straight lines. It is a simple concept. You have several formulae. If you really don't want to remember formula, you can always find out if it is a pair of straight lines condition is met, then you split the equation into two equations. We will do one problem how to split it into multiple equations. You can use that, then you get individual lines, then you can do whatever you want, right? Sum of slopes, product of slopes, whether they are parallel or coincident, all that you can check, right? Okay. So yeah, and then one more thing is, if for a non-homogeneous or general equation, a pair of straight lines equation, this is the condition. Parallel line condition is this one, as I mentioned, parallel or coincidence. Okay, if they are parallel, then the distance between them is given by 2 times square root of g square minus ac by a times a plus b. Okay, if you want to, you can remember this easy. If you don't want to remember, as I said, you split the equation into two equations and then do whatever you want. Okay. And then, other than this pair of straight line equations, okay, we have one more way of representing the multiple equations. Let's say you have a number of lines, all are intersecting at the same point. Okay, so this is called a family of straight lines. Now it's not two; it is more than two. Okay, it can be any number of straight lines. How you can represent? If you have two lines, they intersect at a point. Okay, this is what you call. Okay, they are intersecting at some point. Okay. Then if there are more lines which are intersecting at the same point, we call them concurrent, right? Like this. Okay. So for concurrency, the condition is, okay, you have two lines, equation of two lines, which is one is ax plus by plus c equal to 0, other one is dx plus ey plus f equal to 0. So you will write concurrent family in this way. Some constant m into first line, m into L1 plus n into second constant, L into n into L2 equal to 0. This will represent all the lines which are concurrent at the same point. Okay. This is a family of straight lines with common point of intersection. Hope you understand this point. Same thing you can represent ax plus by plus c plus lambda. Okay, I am taking just n by m, I am calling lambda. Correct? That's the only difference. Okay, both the ways you can represent it. The first one constant is 1, then that's it. Okay, this is called family of straight lines which are concurrent or common point of intersection. Okay, okay. So let's get into the problems now. Given the system of straight lines, okay, a times 2x plus y minus 3 plus b times 3x plus 2y minus 5 equal to 0, the line of the system situated farthest from the point 4 comma minus 3 has the equation. Okay, first thing, understand, you got a family of straight lines equation which will have a concurrency point, correct? We need to find out the line which is among this family, which is farthest from this point. Okay, so to understand that, just I'll explain in the in a diagram. Okay, so this represents family of straight lines with a common point of intersection. So like this. Okay, some two lines basically. One is 2x plus y minus 3 equal to 0, other one is 3x plus 2y minus 5 equal to 0. We can easily find the concurrency point between these two lines. Okay. Now there can be many lines. Okay. And I am looking for a line which is farthest from 4 comma minus 3. So which will be farthest? If you understand this one very well, any line which is angled like this actually, okay, the closest point is here. Okay, not this. This is the farthest. Farthest is this line. Okay, so I need a line which is exactly 90 degrees to this line. Correct? Perpendicular. This is the farthest line, because any other line which is angled, either this side it is close by, correct, or this side, you will get closer than this perpendicular distance between those 2 points. Okay, so only line which will be farthest is the one which is 90 degrees, that blue line. Okay, this is the equation I'm finding out. Okay, so what I need is, I will find the concurrency point, then I will find the slope of this line, then this line slope is at 90 degrees, right? So I can easily find out. That's what I'm trying to do now. Okay, the farthest from 4 comma minus 3 in the system is perpendicular line. Okay, that is the farthest one. Okay, so let's find out the concurrency point first. This is the equation 1. Equation 2, if I solve it, I get concurrency point which is 1 comma 1. Okay, now I know the slope between 1 comma 1 and 4 comma 3, which is nothing but minus 4 comma 3. Okay, but I am looking at a perpendicular line to this, so the slope of perpendicular line is 3 by 4. So equation of the line with slope 3 by 4 and passing through 1 comma 1, which is the concurrency point, is nothing but this y minus 1 equal to 3 by 4 times x minus 1. So equation of required line is 3x minus 4y plus 1 equal to 0. Okay, so hope you understand the question clearly. Okay, farthest from the point is always perpendicular line. Okay, next. Okay, the equation x square minus 2 root 3 xy plus 3y square minus 3x plus 3 root 3y minus 4 represents what? Okay, is it pair of intersecting lines, pair of parallel lines? Okay, with the distance 5 by 2 or 5 root 2. Okay, what is that? A conic section. Which one it represents? Okay, so we know the condition for straight lines, which we can apply and see. Okay, so this is the given equation. The condition for concurrency is AHG modulus of AHG, HBF and GFC, which is nothing but this. If I calculate, I get 0. Sorry, I get 0, which means it is pair of straight lines, equation of pair of straight lines. So now once you know that, you can find out if they are parallel or not. The condition is h square equal to AB is the parallel condition. Okay, so h is nothing but square root of 3. Okay, so h square is 3. AB is nothing but 1 into 3, which is 3. So both are equal. So there are parallel lines. Both are parallel lines. So distance between parallel lines you can calculate using this equation. Okay. So if you don't remember this equation, okay, and if you don't know parallel condition, then how to do? Okay. So that is here. This is the given line. Take the first 3 terms, okay, and square it. Right. Okay. If I square it, this is what it will become: x square minus 2 root 3 xy plus 3y square. So this I can write it as square root of 3y whole square. Okay, so square root of 3y is there, x term is there, minus 2. So this is nothing but x minus square root of 3y whole square minus, if I take 3 common, this is what it will become: x minus square root of 3y minus 4 equal to 0. If I call x minus square root of 3y as k, then I can easily solve this quadratic equation, which is nothing but k minus 4 into k plus 1 equal to 0, which is, these are the 2 equations of lines. So this is how you get the 2 equations of the line from the family of from the pair of straight lines equation. Okay, now you have these two. We can clearly tell, looking at that, these two are parallel because slope is same. Constant term is different, so they are not coincident. So distance between parallel lines is nothing but this formula we know already. Okay, absolute value of constant difference in constant terms, which is 1 plus 4 divided by square root of 1 plus 3, which is nothing but 5 by 2. This is the distance between the parallel lines. Okay. Yeah. Next. Let A be the length of a side of square OABC, with O being the origin. Its side OA makes an acute angle of alpha with the positive x-axis, and the equations of its diagonals are given here. Square root of 3 plus 1x plus square root of 3 minus 1y equal to 0, and square root of 3 minus 1x minus square root of 3 plus 1y plus 8 square root of 3 equal to 0. Then a square is equal to what? Okay. Yeah. So first thing is, yeah, draw the picture, then you will understand everything easily. Okay. So what he's trying to tell is OA is acute angle. Okay. OA is acute angle alpha. Okay, and then the angle BOA is 45 degrees. We know because diagonal actually bisects the angle on the square. Okay, so this is 45. This is alpha. So I know that OB. If OB is the equation of a diagonal, the first one which is given here, this is passing through origin, right? So then this is making 45 plus alpha slope with the angle with the x-axis, which is slope, right? So from that we can derive the angle alpha. Okay, okay. So equation of OB equal to minus a by b, that is nothing but minus root 3 plus 1 divided by minus root 3 minus 1, which is nothing but tan 45 degrees plus alpha. If I expand it, this is what it is, and I can apply component on dividend on this one. I'll get the tan alpha value. Tan alpha is nothing but square root of 3, or alpha is 60 degrees. Okay, now I know this one. Okay, now the coordinates of A is A times, because the side is A, right? A cos 60 comma A sin 60, because alpha is 60, so this coordinates is A cos 60, A sin 60, which is nothing but A by 2 comma A square root of 3 by 2. Okay, now we know this one. This point lies on the second diagonal, correct? Because we have the second diagonal equation here, AC. Okay, so A lies on AC, so you substitute these values in the AC. So you get, if I substitute, this is what I get. Square root of 3 minus 1 into A by 2 minus square root of 3 plus 1 into A square root of 3 by 2 plus 8 square root of 3. If I simplify this one, I get the value of A. A is nothing but 4 square root of 3. So A square is what I am looking at. A square is nothing but 48. This is the answer. Okay, next. A line passing through the point P A comma 0 makes an acute angle alpha with the positive x-axis. Let this line be rotated about the point P through an angle alpha by 2 in the clockwise direction. If in the new position, the slope of the line is 2 minus square root of 3 and its distance from the origin is 1 by root 2, then the value of 3 alpha square tan square alpha 3a square tan square alpha minus 2 root 3. Okay, so basically look at the final expression. I need to find out a and alpha. Okay, this is first thing. Okay, now draw the picture, then you will understand it very easily. Okay, PQ is my original line. Okay, P is a comma 0 because it is passing through the x-axis at a comma 0, right? This is rotated. Okay, this is rotated about this point P by alpha by 2 degrees, correct? So my new position is PR, and PR makes alpha by 2 with the P makes alpha by 2 with the x-axis. This is what is given, correct? If the new position, okay, new position, the slope of the line is 2 minus root 3. So slope of PR is 2 minus square root of 3. This is where we'll start the work from. Okay, slope of PR is tan alpha by 2, which is nothing but 2 minus square root of 3. Tan alpha is nothing but, in terms of tan alpha by 2, if I write 2 times 2 minus 2, 2 minus square root of 3 by 1 minus 2 minus square root of 3 whole square. If I simplify, what I'll get is this value 1 by square root of 3, that is tan alpha, which is nothing but 30 degrees, correct? So alpha is 30 degrees. Now I know the alpha value. I need to find out the a value. So how do you get a? Okay, if the line PR is passing through a comma 0 and 2 minus root 3 away from the origin, right? So the line which is passing through a comma 0 is nothing but this value. Okay, 2 minus root 3 is the slope actually. 2 minus root 3 is not away from origin, it's the slope. Okay, so y equal to 2 minus root 3 into x minus a, or 2 minus root 3 to x minus y minus a times 2 minus root 3 equal to 0. This is the equation of PR now. Okay, now this line is how much? It is 2 minus square root of 3 distance from the origin. So if I substitute it, okay, origin is x and y are zeros. So absolute constant value, which is a into 2 minus root 3 divided by, okay, a square plus b square, that is nothing but 2 minus root 3 whole square plus 1 square. If I simplify, and this is equal to 1 by root 2, which is given in the question. So if I simplify this one, what I'll get is a square into 7 minus 4 root 3 equal to 8 minus 4 root 3 by 2, or 4 minus 2 root 3. Okay, so my a square is nothing but this value. Okay, denominator third I want to remove, so I multiply with the conjugate. What I'll get is 4 plus 2 root 3. A square is 4 plus 2 root 3. So now given expression, I have all the values. Okay, 3a square 4 square alpha minus 2 root 3 is nothing but 4. This is the value. Next, consider the lines given by L1, which is x plus 3y minus 5 equal to 0, L2 3x minus ky minus 1 equal to 0, L3 5x plus 2y minus 12 equal to 0. Match the statements in column 1 and column 2. Okay, so these are the statements which are given. So you look at all the statements. What we need to check is, one is concurrency condition and parallel condition. With these two, we can solve this problem, right? First, let's check the concurrency. So we know concurrency, we need to just form a matrix and check that one. Or first find out the point of intersection of first two lines, which is x plus 3y minus 5, L1 and L3 basically, right? So L1 and L3 point of intersection is 2, 1. So if I substitute that in the second equation L2, which is 6 minus k minus 1 equal to 0, k is 5. Okay, so A and 5, A and S are linked actually. Okay, the concurrency condition is k equal to 5. This is okay. Next is, if L1 and L2 are parallel, L1 and L2 are parallel, then the slope should be 1 minus 1 by 3 equal to 3 by minus k, which is implies k equal to minus 9. So k equal to minus 9, then you will have at least two lines parallel. Okay, but what about if L1 and L2 and L3 are parallel? Then the condition is k equal to minus 6 by 5. Okay, these two are the conditions where you have at least two parallel lines. So L1 and L2 and L3, if you take the k equal to 5, that is L2, L1 and L1, L2, L3 form a triangle if there is no parallel lines, right? So C condition is nothing but this one, 6 by 5. Okay, C is nothing but R. Okay, 5 by 6 basically, sorry. Okay, so this is mapped now, and then you have D, that is L1 and L1, L2 and L3 do not form a triangle if any of the above three are correct, right? Correct. So for D, P, Q, S, all three are correct. Okay, this is important. All three conditions are correct for D. Okay, and for B, which is two parallel conditions, P and Q both are correct. Okay, so this is how we should map it. Yeah.